In this tutorial, we will work on dividing like bases. We will be following the following two rules. Keep the base the same, just as when we were multiplying like bases, but instead of adding the exponents today, we're going to subtract the exponents. So let's get started. Here are some examples for you to look and learn from. You'll notice the first one over here on the left, 7 to the 5th divided by 7 to the 3rd. My base is 7, and that's what my answer says. So I keep the base the same. But power of 5 divided by the power of 2, we don't divide, we subtract. So 5 take away 3 is 2. Over here in this second example on the right, you'll notice that my base of x stays the same, but 3 minus 7, we always start with the numerator. Numerator minus denominator. And when 3 take away 7 happens, we get a negative response. So you may need to go one step further and use your negative exponent rule to rewrite your final answer. You'll notice with this one here on the bottom that my base remained the same, 3, but 4 minus 4 was 0. You might remember from a few lessons ago that anything raised to the 0 power is equal to 1. Now the last one here, notice my base is an item inside parentheses. So the parentheses remain and the entire item remains. Now look carefully here at this math. The rule is to subtract the exponents. Our exponents are 4 and negative 3, but the rule says to subtract them. So this would be the actual math sentence. And when we subtract a negative, we actually add them together here, right? 4 plus 3. And that's why the answer was 7. Take a moment to pause this video if you need to look at these a bit longer. We can do the same math if we have coefficients as well. So because in our previous unit we learned how to multiply like bases and then we made it more challenging by adding coefficients, I'm just going to start with the coefficients here since it should be somewhat familiar to you. A coefficient is this large number in the front that is multiplying the base here. So we have 36x to the 7th and 3x to the 3rd. So we really have like two separate problems here. 36 divided by 3 and x to the 7th divided by x to the 3rd. 36 divided by 3 is 12, and 7, my numerator exponent, take away 3, my denominator exponent, is 4. So again, we pull the coefficients out separately, we divide them because it's a division problem, and we write that coefficient first. Then we keep our letter base the same, a stays a, and then we write our numerator exponent, we write our denominator exponent, and we write a minus in the middle. Pick up your calculator if you don't know your integer rules and type -3 subtract -5. If you do know your integer rules, then you know that subtraction means to add the opposite. So -3 plus 5 is 2. Take a moment to pause this video if you need to look at these rules further. All right, it's time for you to try some simple examples. No coefficients here. Let's just try keeping the base the same and subtracting the exponents. Pause the video now. All right, let's take a look at your work. First one should have been x squared. Second one should have been 5 to the 4th. Again, it says write using positive exponents, so I don't do the math. Just leave it as 5 to the 4th. Be careful here with number 3. Y is the base, but -8 will be your new power. It says positive exponents only, so I need to flip that over. Number 4, keep the base the same, subtract the exponents, and if you get a power of 0, you need to simplify it to 1. All right, how did you do? Let's take a look at some other examples now. Pause the video and give these a try. All right, I hope you took the moment to pause the video and actually try these problems. Don't forget you start with your numerator, -3 minus -4. The base will remain the same, but our power here will be 1. Anytime you have a power of 1, you can leave it invisible. Number 6 would be 5 minus -5. That would make 10. Number 7 is actually two questions. So first I'm going to compute the exponent for a to the 2 power. And then don't forget there's an invisible 1 down there. And 3 take away 1 is also 2. For number 8, I'm going to get r to the negative third and t to the 14th. And part of my answer has a negative power and part of my answer does not. So the t does not have a negative power, only the r does. So only the r is going to get flipped to the denominator. Only the r we will take the reciprocal of. So I'm going to leave the t to the 14th in the top, but the r to the third power will move down to the denominator. So that's t to the 14th divided by r cubed. All right, you want to try some with coefficients now? You got this. Take a moment to pause the video and really give this a good effort. Okay, this is the end of our video here, so let's see how you did. 14 divided by 7 is 2. The base is w, and 8 minus 5 is 3. Done. 30 divided by 2 is 15. The base is a. 6 minus 2 is 4. We're done. Now we're going to get into some more complicated questions here. Negative 6 divided by 2 is negative 3. X, 9 minus 6 is 3. And 4 minus 3 is 1, so I'm not going to write it. All right, this one is a little bit tricky because 2 cannot be divided by 8, but it can be simplified. So 1/4. Now r cubed, take away negative 3. So 3 minus 3 is going to be r to the 6th power. And notice I'm putting the r in the numerator, right? Because that's where your answer will go. Now this one is a 1. 1 minus 7 is s, whoops, excuse me here, s to the negative 6th power. Now that's a problem. You can't have a negative power in your answer. So anytime you have a negative power, you need to flip that item from the top to the bottom, right? From the numerator to the denominator, you're going to write the reciprocal. So I'm going to take this s to the negative 6. I'm going to flip it over, and once I do that, it becomes positive. All right, hopefully you got these right. That concludes our video on dividing like bases.